right now. So it's time for today's LeetCode Daily Challenge. Today is April 26th, 2020, 21st. And today's question is furthest building you can reach. So I checked. This is question number 1642. Furthest building you can reach. And I'm a little bit concerned about this question because I'm not sure if I can solve this because when I search it and the history clear shows that I've attempted this question before and I never resolve it. So especially after yesterday's medium question, the rotate a matrix by 90 degrees, and it spent me a good 1 hour and more to solve that problem. Today I am concerned about the ability of me solving a medium question, especially that I have attempted this before. So let's try it. Anyways, okay, so you are given an integer array of heights representing the height of buildings. And you also given some bricks and some letters. Okay, you start your journey from building 0, so array 0, moving to the next building by possibly using bricks or letters, while moving from building I to building I plus 1, which is next building. If current building's height is greater or equal than to the next building's height, you do not need a ladder or bricks. So if it's for like there is a cute animation on the problem here. So when the next building is lower, you clearly don't need any ladder or bricks, but when the next building is higher, you either need one ladder, right, or a lot of bricks. So if current building's height is less than next building's height, you can either use one ladder or the height difference of bricks. So return the furthest building index 0 based you can reach if you use the given ladder and the bricks optimally. Okay, let's see the example here. I would think that this cute little animation is based on the first example. So it's 4, 2, 7, 6, 9, and you have 5 bricks, 1 ladder. So according to the animation, the furthest you can reach is 0, 1, 2, 3, 4. So the answer is 4. So when you go to the building 1, you don't need any ladder nor bricks, right? Because it's lower. But when you go from 0, 1, from 1 to 2, from height 2 to height 7, you either need 5 bricks or 1 ladder. So in the animation, it shows that this little cute guy used all the 5 bricks. And then you don't need anything from 7 to 6. But from 6 to 9, you need a ladder. So the optimal answer for this one is 4. Because if you use a ladder here, and then in here it only costs you how many bricks? 3 bricks, and you still have 2 bricks. But then 2 bricks won't bring you from 9 to 14 because the difference is 5. Okay, so this question requires you to use the bricks or ladder optimally. Okay, So now we have a second, third example, and the constraint is that the height is between 1, so it won't be 0. Okay, so it will at least have one building, at most have 100,000 buildings, 10 to the 5, and the height is 10 to the 6, and you will have 10 to the 9 bricks, and you will have between 0 to the length to the height length. So for how many building you have, you could have the same amount of ladder, so which means the ladder is definitely enough for you to go through until the end. Okay, how about let's see the hint. Hint 1, check whether you can reach the last building or not. Really? Okay, let's see the second hint. You'll have to do a set of jump, of course, and choose for each one whether to do it using a rope or bricks. Rope? No, I guess it means ladders, right? It's always optimal to use ropes, nah, ladders, in the largest jump. Yeah, I know, okay. So hint 3, iterate on the buildings, maintaining the largest R jumps and some of the remaining ones so far, and stop whenever the sum of bricks is. Okay, so for the example 1, the largest difference is, I guess, is 5, right? Yeah, 5. So from here to here is 5, from here to here is 5, and you have 5 bricks. So of course you need to use the ladder in the largest difference, but it doesn't mean that you can use the ladder in here, right? Because you will never reach here, so you cannot just sort the difference. So like the third hint says, that you need to iterate on the buildings one by one. So I think my thought will be like, you use all the ladders first, right? And then use it until you don't have any ladders anymore. And once you use up all the ladders, you find all the difference that you have encountered and replace the minimum one with bricks so that you can use less bricks, and that will be the optimal solution. Okay, let's try it. So we need a heap. We need a min heap. Okay, so let's try. So 20, so idx equals to 0, which means it's the current building, and we need a priority queue of the difference, so it's integer. Okay, so I will just call it PQ, new priority queue. Okay, and so index IDX is the current one. So I already have the initial value, because the reason why I declare it first is because I want to, in the end, return the IDX, right? Because that's the furthest one that we can reach. So if the IDX less or equal than heights, dot length. Oh, okay. So probably should -1 because I'm going to check between this and that, right? Maybe. And id x plus plus, and then int diff equals to height. Current one. Oh, I can't spell. Current one. No, I need the next one. And height. So that's the difference between the next one and the current one. And if diff is less or equal than 0, which means if the next building is less, if the current building is greater or equal than the next one, we don't need anything, right? So if this is less or equal than 0, which means current building is greater or equal than the next one, we don't need anything, so we can continue to the next building. Otherwise, we check if we still have ladder, right? So ladders, ladders. So if we still have ladders, then we use one ladders. Hold on, I need to do a lot of different things in here. First, we use one ladders. Minus. And then we put the difference into the queue. So pq dot offer the diff, and then continue. Okay. Now what if we don't have any letters, right? If we don't have any letters, we need to check if we have bricks. Okay. So when using bricks, we are going to take the fewest prior difference from the PQ and replace the letter with the bricks, right? So let's try. So if now that we don't have letter anymore, we need to see if so if then what about the next one? Do we need to put the next one in first or not? I think we need to. So okay, let's see. Now we need to use bricks. So let's assume that currently we don't have anything in the queue. So if pq dot size or just PQ. If PQ dot is empty, right? Then we check. Then we check if bricks, B-R-I-C-K, bricks is less than diff, then break. Because we can proceed further. We break and we return index, which is the current building. Otherwise, bricks minus equals to diff and continue. So that's when we don't have PQ. And now if we do have something in PQ, then we will do a peek. We don't even need peek, so we will just use like diff equals to PQ dot pool. So that will be the smallest one. Oh, okay. So I probably just do a while in here, right? I do a while until we have enough bricks to continue to the next level. So I don't know. No, because no. I think it's okay because now we don't have bricks anymore. We will take the smallest out from the PQ and check again. If like bricks is smaller than diff, still we break because we can't reach any further. Otherwise, bricks minus equals to diff, and then we can continue. Oh no, and then because we add one letter back, LADDER plus plus, but we exchange for one letter, we cannot increment index because we actually did not progress, right? But because I'm using for loop, it's going to increment the IDX, so it's ugly, but I guess I need to minus in here. And because BECAUSE, we did not progress. Okay, I guess that's it. Let's try it. Compile error. Line 6, I have a typo. Try again. What? Line 6, I still have a typo. Oh god, heights. I have so many typos. Oh, where is this? 24 letters. Okay, the first test case passed. And what? Custom test case. There are 3 of them, so let's do both. So let's try the 10 and 2. Okay. 10, 2. Okay, it's wrong. I know it. So let's see if all of them are wrong. I knew it. I knew I will have trouble. It's not that easy. Okay, got. So what's wrong with the last one? My answer is 1, 2, 3, 4, 5. No, 5 is 0, 1, 2, 3, 4, 5, 6, 7. But the correct answer is this. So why? Why? 10 and 2, 10 and 2. So let's try it. Try my. So we use a letter, 1 letter, no letter, 2 letter, and now we don't have letters, but I can still go through. And now in here our difference is 15. And because we don't have letters, we replace the smallest difference, which is here. So we replace here with bricks, so we spent 5 bricks. Now we have 5 bricks. Okay, let's put it in action in here. So this is our example. So from here to here, we spent 1 letter, 1 letter, 2 letter, 2 letter, based on our right. And here we replace, we don't have any letter anymore. So in our PQ, we have 8 and 5. So 5 will be here. And now in here we don't have letter anymore, so we take out 5. So we put 5 in here, and we don't increment I, so I is still here. So I minus and plus, and here the difference is still, and we have 1 more letter. And then now we use a letter to climb to here, 18, and we put 15 here, and now we don't have letter anymore. And now I sort of know what's the problem, because we have to compare the diff, so I cannot just disregard the diff in here. So I still need the original diff, so I will prior, or I will just give a mean because it's pulled from the PQ. Or I can just peek. And if diff is smaller than min, or diff is larger than no. Okay, so if diff is larger than min, we do a pull. Okay, no, I have to know if we are going to increment I, right? So we are going to use, okay, so if the diff,
Sorry, I'm having trouble connecting to the internet.
okay.
It looks like a router issue, so try restarting it. Unplug the router, wait 10 seconds,
Okay.
then plug it back in.
Okay, my Alexa is telling me I have network issue. God, why you are telling me this now? Oh, okay, where were we? So now, if the diff is larger than min, then we pull it, and then we do this, and then we do this. Okay, I probably need to do a lot of things. If diff is too big, we get the diff from the pool, and then still we need this. Otherwise, we do this, I guess. Else, if diff is small or equal than min, which is the next one, we actually can increment I, right? So else is diff is larger or equal than, oh no, smaller or equal than min, right? Then let's increment. And I still need to check if, so I still need to do this, and I still need to do this, right? And I will still, do I increment letter? No, because I didn't pull anything from the PQ. And do I decreasing this? No. So I guess that's it. Let's try it. Yeah, that's it. But I think this part is too ugly. I can probably make it more elegant, because I'm doing the same thing twice, like bricks and this. So I am doing the same thing twice. But anyway, we can do that later. Let's see if this is the correct answer. So let me have another random array again. And let's not make it too big. And 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So let's have 4 bricks and 2 leather. And let's try it. It looks like it works. Let's submit. It works. It works. It works. It works. Let's see how we do. So the time, this is the runtime. So runtime is good enough, 87%. And the space is also good enough, it's 91%. So that's it for today's. And what's the time complexity? Because we are going through one by one, it looks like it's n, but because we are using a PQ, so in any case, this time complexity should be n log n. Because worst case, we are going to put everything in the PQ. And the space complexity is, of course, again, because we have a PQ, so it's O of n. Okay, so that's today's daily question. We are doing better than yesterday. I only spent 30 minutes on this. Yoo-hoo! So, thank you for watching. I will be seeing you tomorrow. Good night. Bye.